The purpose of this video is to help you find the missing side of a right triangle by using right triangle trigonometry. As we're going through the video, you need to be able to answer these 4 questions when you get to the end. How do you know if you should use trigonometry? How do you know which trig ratio to use? Should you use sine or cosine or tangent? How do you find the correct decimal value from a trig table? And how do you solve the equation once you have the equation set up? In order for you to understand how right triangle trigonometry works, it's very important that you understand how similar triangle problems work. So we are going to begin by doing a similar triangle problem. Out of the 6 triangles that are on this page right now on the screen, in every triangle, we know the yellow side. In every triangle, the green side is missing, except for in triangle B, which makes that triangle very important for similar triangle problems. The other thing that we should notice is all of the triangles are similar because they're all 31 degrees, except for C. C is a right triangle like the others, but it does not have a 31-degree reference angle, so C is not similar to A, B, D, E, and F. So to start our similar triangle problem, we're going to compare the smaller triangle B to the larger triangle F. So we'll begin with the corresponding sides. 2.16 in the smaller triangle corresponds to Z in the bigger triangle, and 3.60 in the smaller triangle corresponds to 5.05 in the bigger triangle. So once we have that proportion set up, we're going to find the cross product. So Z times 3.60 is 3.60Z, and 2.16 times 5.05 is 10.908. And then to continue to solve this problem, we have to divide both sides by the number that's in front of Z. And so when we do that, we find out the length of side Z in triangle F is 3.03 inches. So the method we used in solving this problem is we made a fraction out of the green side in the small triangle over the green side in the larger triangle, and the yellow side in the smaller triangle over the yellow side in the larger triangle, and we found the cross product, and then we found the length of side Z. The next thing that we need to understand is that we could do the same problem but slightly different, and that slight difference will move us one step closer to right triangle trigonometry. Here we go again, but doing the same problem in a slightly different way. I'm going to write 2.16 over 3.60 equals Z over 5.05. So the way that I've done the problem this time is I took the small side, the green side of the small triangle, over the yellow side of the small triangle, and the green side of the large triangle over the yellow side of the large triangle. And when I find the cross product, I will have 3.60Z, and then when I multiply 2.16 times 5.05, that's 10.908. And then I divide both sides by the number that's in front of the Z, and my final answer comes out to side Z equals 3.03. So you can see that whether you compare the small to the big and the small to the big, or you compare the green to the yellow and the green to the yellow in the same triangle, you get the same answer. So the next thing that we need to do in order to go one step closer to right triangle trigonometry is we need to label the sides of these triangles. So in B, this is our reference angle. These two sides make up the reference angle. The longer is called the hypotenuse, the shorter is called the adjacent, and the leftover is called the opposite. When I go down to triangle F, here's my reference angle. It's made up of these two sides. The longer of the two sides is called the hypotenuse. The shorter of the two is called the adjacent, and the remaining side is called the opposite. And this is what's important about what we just did. If you look inside the purple box and the blue box, we got the same answer. But in the blue box, we're one step closer to using trigonometry because 2.16 is the opposite side and 3.60 is the adjacent side. So we took the opposite side over the adjacent side in triangle B, and Z is the opposite side, and 5.05 is the adjacent side. So we took the opposite over adjacent in triangle F. And if you've been paying attention to what Miss Olson hates, Miss Olson hates SOHCAHTOA. And right now, we're using the opposite and the adjacent. So we're actually using the TOA part, or we're solving this problem by using the tangent ratio. The tangent ratio is the opposite side of a right triangle over the adjacent side of that triangle. And because triangle B and triangle F are similar, they both have two congruent angles, all similar triangles will have the same ratio when we write the opposite over the adjacent. Now you're looking at a table of trigonometric ratios, and this table is what makes learning trigonometry better than just knowing similar triangles. When you know similar triangles, you have to have a smaller triangle and a bigger triangle, and in one of those triangles, you need to know all of the corresponding sides that match up with the ones that you don't know in the other triangle. So this chart or this table solves that problem. So what we're going to do is, if you take a look at this table, at the top of this column it says tangent, and in this row it says 31 degrees. So the way you use this table is, we were using the opposite and adjacent side, so we were using tangent, and our reference angle was 31 degrees, and we look and see where those intersect, and those intersect at 0.6009. And so what this table is telling us is that the tangent of 31 degrees is equal to 0.6009. The trig table is telling us that in every 31 degree right triangle, if you take the measurement of the opposite side over the adjacent side and divide it, the answer will always come out to 0.6009. Did that really happen in our problem? Well, if we look at what we have here in problem in triangle B, the opposite side was 2.16 and the adjacent side was 3.60. And if we divide the opposite and the adjacent on our calculator, the answer comes out to 0.6000. So in our triangle, when we took the opposite side over the adjacent side and divided them, we did get almost the same value as the trig table. And you might say the trig table is a little bit off, but that's not really true because our numbers are rounded off to the nearest hundredth. Actually, our measurement is a little bit off, and 0.6009 is the number that you should get if you measure the opposite side and adjacent side more accurately and divide them. So how does this help us solve right triangle trigonometry problems? Well, it takes this part out of the problem. now we can do the problem even if we don't have triangle B. So if we just had to do the problem like this and I said, hey, find side Z, we wouldn't have another triangle to compare it to because the rest of the triangles on the slide, they are all missing the green side as well. So how would we do the problem? Well, we would start out like this. We would know that the opposite over adjacent in every single 31-degree right triangle is going to equal the opposite over the adjacent in every other 31-degree right triangle. Well, in the one that we're working with, the opposite side is Z and the adjacent side is 5.05. But since we don't have triangle B anymore to go back to find those values, how long is the opposite side, how long is the adjacent side, we don't know that, but we do know that because we have the table to look at. And in the table it says in every 31-degree right triangle, when you take the opposite and adjacent and divide it, it's always going to come out to 0.6009. So this would be our equation if we were using the trig table to solve the problem instead of two triangles and making it a similar triangle problem. So the last thing we need to do is just solve this equation. So what most students like to do is they think of that decimal on the left as a fraction by writing it as a fraction with 1 on the bottom. And then you find the cross product just like we did previously. And so Z times 1 is Z, and 0.6009 times 5.05 is 3.03. The same exact answer that we got when we used similar triangles involving two triangles. Here's one more quick example. We're going to find the length of side X from triangle D. So the first thing that we're going to need to do is circle the reference angle and trace over the two sides that make the reference angle. The longer of the two is the hypotenuse, the other one is the adjacent, and then the remaining side is the opposite. So if we want to find out what the length of side X is, we're going to put the opposite over the adjacent equals the opposite over the adjacent. And in our triangle, triangle D, the opposite is X and the adjacent is 2.96. Normally, we'd be looking to a second triangle to try to find out what its opposite side and its adjacent side was. But since the trig table told us that every single 31-degree right triangle has an opposite over adjacent that is equal to the decimal 0.6009. So instead of looking towards a second triangle to find out the information, we just look at the trig table and we know that X divided by 2.96 is going to equal 0.6009. If we make the left side of the equation into a fraction, now we have to find the cross product. So 1 times X is X. And 0.6009 times 2.96 is 1.778664. Depending on what the directions would say, you would round off differently. But if we're going to round off to the nearest hundredth, we would want to keep that much. And our final answer would be 1.78 when we round it off correctly. And that would be the length of side X. In the last problem, we were dealing with 31-degree right triangles. In this problem, we have 3 20-degree right triangles. We're going to start out with the biggest right triangle, the one that's yellow right now. And if we measure, we can see that that side is 7.3 centimeters. And we know that the other side is 20 centimeters. So if we label our triangle, we'll have our reference angle, the two sides that make the reference angle, hypotenuse, adjacent, opposite. So the tangent of 20 is going to be the opposite over the adjacent, which is 7.3 over 20. And if we write that as a decimal, the opposite over the adjacent, or the tangent in this 20-degree right triangle, will be equal to approximately 0.365. Now we're looking at the middle size 20-degree right triangle, and that triangle has a 5.6 side and it has a 15.4 side. So if we label our triangle reference angle, this is the hypotenuse, this is the adjacent, this is the opposite. So if we write the opposite over the adjacent, that's going to be 5.6 over 15.4, which is equal to 0.36363636. And so the tangent of 20 degrees, when we look at the middle size triangle, is 0.363636. Now the smallest 20-degree right triangle has a side that's 3.3 and a side that's 9.2. So this is our reference angle. These are the two sides that make up the reference angle: hypotenuse, adjacent, opposite. So the length of our opposite side over our adjacent side, on this problem the opposite side is 3.3 and the adjacent side is 9.2. And if we divide 3.3 and 9.2, our answer will be 0.3586965. That's what it'll look like. So for this smallest triangle, the tangent of 20 degrees came out to that number right there. Now we're looking at the trig table. And on the trig table, it will give us the most accurate measurement of what the opposite divided by the adjacent is in any 20-degree right triangle. So again, the way you find the information that you need is you go to the column that has your trig ratio in it, and we're working with tangent. You go to the row that has your angle, and our reference angle is 20 degrees. And you find the place where your column and your row intersect, and that number, which for us is 0.3640, that is the tangent of 20 degrees. And you can see that that's slightly different than our large triangle and our medium triangle and our small triangle. But that's because the measurements of the sides of our triangle are taken in a way that's not very accurate. The trig table is very accurate. So I'm just trying to get you to see that in any 20-degree right triangle, if you take the opposite and divide it by the adjacent, you're going to get about the same number. And what that number actually is in its most accurate form is 0.3640. Here's another quick example. This is a 20-degree right triangle, and we are looking for side X. So I'm going to start out, circle the reference angle, find the two sides that create the reference angle. That's the hypotenuse, that's the adjacent, that's the opposite. We're trying to find the opposite, but we know that the adjacent side is 17. So we would normally do this problem like this. The opposite over the adjacent of one triangle will equal the opposite over the adjacent of another triangle. Our opposite is X, our adjacent is 17. But now we don't have another triangle with another opposite side and another adjacent side to compare it to. But on our trig table, it just told us that the tangent of every 20-degree angle is 0.3640. So what that means is the opposite over the adjacent for every 20-degree right triangle will always come out to the decimal 0.3640. So instead of writing the opposite side and the adjacent side, we're just going to put the decimal value of the opposite divided by the adjacent. When most people solve this problem, they put a 1 on the bottom to turn it into a fraction. And now we're going to find the cross product. And x times 1 is x. And if we do 17 times 0.3640, our answer is 6.188. And if we want to check and see if our answer is done correctly, we can put the ruler back up there, and the length of side x looks like it's about 6.2. Our answer was 6.188. So we know that we got the right answer on this problem. Not every problem in right triangle trigonometry is a tangent problem. So in this problem, I'm going to circle the reference angle, and the two sides that make up the reference angle, the longest is the hypotenuse, the shortest is the adjacent, and the remaining side is the opposite. So for the first time, we know the length of the hypotenuse, and we are looking for the opposite side. So what we need to do, look at our SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Well, in this problem, we are not looking for the adjacent side, and we do not know the length of the adjacent side. So we wouldn't have anything to fill in to the bottom if we use tangent, and we wouldn't have anything to fill in on the top of our fraction if we were to use cosine. The only trig ratio that has a spot for the q for the opposite and a spot for the 10 for the hypotenuse is the sine ratio. So in this problem, we will use sine. So to set the problem up, we have sine equals opposite over hypotenuse and opposite over hypotenuse. In our triangle, the opposite is q and the hypotenuse is 10. And in our other triangle, well, we don't have another triangle, but we do have a trig table. So we know that if we go to the trig table and we find our trig ratio, which right now we're using sine, and we find our angle, and our reference angle is 63 degrees, and we find out where sine and 63 degrees intersect, they intersect at the decimal 0.8910. So we know that in every 63 degree right triangle, when you take the opposite side and divide it by the hypotenuse, you will get the decimal 0.8910. So if we want to solve this problem, we make that into a fraction and we find the cross product. So q times 1 is q, and 10 times 0.8910 is 8.910. And that would be the length of the opposite side in our 63 degree right triangle. In this problem, our reference angle is 76. We trace the sides of our reference angle. The longer is the hypotenuse, the shorter is the adjacent, and the leftover side is the opposite. So in this problem, we're trying to find the adjacent side, and the only other side that we have a measurement for is the hypotenuse. So if we look at our SOHCAHTOA, we need a place to put our x. So our x is going to have to go in for the adjacent side, and we need a place for our h. Our 5.73 is going to have to go in for the hypotenuse. Also, we don't know anything about the opposite side. So if we were to use tangent, we wouldn't have anything to put in place of the O. If we would try to use sine, we wouldn't have anything to put in the place of the O. But we can put our x in for the A in cosine and our 5.73 in for the h in cosine. So our problem is going to be a cosine problem. It will be adjacent over hypotenuse equals adjacent over hypotenuse. And our adjacent side is x, and our hypotenuse is 5.73. And then we don't have another triangle with another adjacent side to look at and another hypotenuse to look at, but we do have the trig table, which tells us in every 76-degree right triangle what decimal value the adjacent divided by the hypotenuse will have. So to find that number on the trig table, your first step is find the right column. We get 1.386. So the length of the adjacent side of this 76-degree right triangle is 1.386 miles. Here are the 4 questions from the beginning of the video. How do you know if you should use trigonometry? You can use trigonometry to find the missing side of a right triangle as long as these 3 conditions are met. It must be a right triangle, you must know one reference angle, and you must know one side. How do you know which trig ratios to use? When the labels on the known side and the side that you must find are the opposite and hypotenuse, you will always use sine. If they're the adjacent and hypotenuse, you will always use cosine. And if they're the opposite and adjacent, you will always use tangent. How do you find the correct decimal value from the trig table? You find the intersection of the column with the trig ratio and the row with the reference angle. And how do you solve the equation once you set it up? You find the cross product. Usually you put a 1 underneath the decimal value. Find the cross product and divide, and you will know the value of the variable.